Hi, this is Ingrid Salim, and I'm currently a science teacher at North Davis Elementary. I've taught science for 26 years in Davis at various schools and know many of you. And this is a screen slideshow of ways to use technology, but also ways to differentiate content and output as we play with all these new approaches to curriculum like Common Core and NGSS. So you're going to see a mixture of a variety of different techniques in a pretty short span of time. This image right here is clearly not a technologically based image. It is a creation of students in 5th grade at North Davis trying to understand and make sense of a phenomenon that they viewed, but it easily could be turned into technology, and the point is that whatever we have students do should really be centered around making sense of something. For the specific show I'm going to present here, I did a process with elementary students, and I'm going to highlight some work that the 4th graders did, where I actually did have them do some very traditional comprehension questions out of the textbook and using worksheets that came along with some text that we had. And then we had a very frank discussion about whether those approaches had helped them make sense of text or whether they had made them feel like they could show what they understood, etc. And pretty unilaterally, the students claimed that no, these approaches with worksheets, the questions that were asked, were boring, did not engage them. And in fact, I could experience the energy level change in the classroom whenever that was what we asked them to do. So even if the text was interesting, or the content they were working on was interesting, if the way that they were being asked to process or synthesize wasn't, you could feel the energy change. So then I had students brainstorm ways to other ways, alternative ways to make sense of content. And many of you are using these in your classrooms already. These include Avid strategies. We'll see some examples in a second. And lots of other ways. So this is really just a reminder and an encouragement for us all to explore various methodologies to help students make sense of text and of content that they've been exposed to in whatever way. And although I'm going to focus specifically here on a text example, really this does apply to any lecture material if we're providing students information in that way, any lab material that allows them to construe content from that material, video, anything that becomes a source of information and content and ideas. So this was the list that my 4th graders came up with, and honestly it is pretty much the same as every such list that's been generated in my classrooms for the last 20 years since I've been doing something like this. Posters, that's pretty an obvious one. It is also, it sounds extremely simple on the surface, but I have found that actually it's quite difficult for students to capture content that they really do understand, and it's also harder to share the work and share the learning. So it is not my favorite choice. Some students do really well with this option. For others, it's a way to slack off. So I tend to distract them from this option as often as I can. Slideshow, which is what you're going to see an example of here in a minute, is now a possibility with Chromebooks, and I do find that that is an incredibly engaging option since students can do that individually and they can create their own kind of task, they can set their own pace, and they have a lot of control over the product that they make. I do think that Da Vinci, in their practice of project-based learning and their one-to-one ratio of devices, has already realized this potential, and so they're a source for us as well to learn kind of how to do these kinds of projects. Making a video, which sounds very engaging and in fact is, and yet it's very hard to get students to focus on just content. So there has to be a very specific prompt and a lot of checking in to make sure they really are. But it's also very sociable and just a really fun way to engage in content if there's something that warrants that. Text graphics are what I call the combination of text and images put onto one sheet of paper, and generally by one person, not a poster. And because in science this matters, and in math probably too, that there are lots of abstract phrases and language that needs to be made sense of, simply recreating language isn't enough to show comprehension. So showing diagrams for what things mean is pretty important. Just taking notes, there still are students who are incredibly linear and really do want to make outlines, and they should be allowed the opportunity to do that if that is the way that their brain makes sense of things. But it isn't the way that most people make sense of things, and that's the other thing we have to remember. There just are many different ways that the brains work, our human brains work. Essay summaries, there are still students who can read a text, and depending on the level of that text, they can synthesize it in their head, maybe with notes, maybe without, and then just crank out a summary. And again, those students should be allowed to learn and synthesize to the degree that they can. And I would argue that we should be challenged to find content and sources for those students that do require them to do a higher level of synthesis so that they can get used to that and not just sail through. A creative synthesis is a concept that was denoted by Avid. They have entire lists of ways for students to do this, and a number of our junior high teachers, I believe, are already using them. On the side here, the image on the right that looks like a beaker is basically that. It's a poem that creates, it's a chemistry poem about moles, and I know that's really exciting, with an image that student associated with it. Chemistry, basically, like an alchemical kind of thing. And above that is an image labeled bonds, which is about chemical bonds, and these are, this student chose to create analogies to demonstrate her understanding of bonds, and to do that she created a line of shoe wear, which many of us might even want to wear, although that heel is really high. But they were actually beautiful examples of trying to make sense of what things meant. And then finally, it's not really showing here, but that final line is a brochure, and many of us have used that kind of a possibility as a product for many years. This is just one that was created with the computer in terms of images and text, and in fact it's not simple to create a brochure that can actually fold, like a 6-sided brochure that's double-sided on a piece of 8.5 by 11 and that folds in all the right way. So in fact it's actually another very interesting piece to assign students and have them do, or to allow them to choose. And all three of these are examples. One is something you could use with tech, the others could easily be, and if our students had access to technology regularly today, I imagine that most of them would design these sorts of things using technology. So the rest of this is really about a very specific task that I did with 4th grade students, and I did it with others as well, but this is the one that I chose to document. It was around text. It's around some trade science texts that we ordered very recently, so they're brand new, and there's a lot of different topics. This was not one text for everyone. It was within the standard of life and organisms on the planet. So certainly students got different things out of it, but because it was so many different choices, it's naturally differentiated from the very beginning. This slide you're seeing right now is the prompt that I gave students, which allowed them to either read the text on their own first and then go back and create something, or to do it simultaneously. And it was about half and half the students actually were able to do that, or did choose to do that. I gave them a prompt to use 7 to 10 slides and to use bullet points, and we looked at a number of basically PowerPoint slides to see what was effective. And I gave them the prompt to use at least one image per slide, which also meant they had to learn how to go and get that image off the net and put it into a slideshow. So they were pretty captivated with this process. These are the texts that they had to choose from. There were a couple of others as well, and they're all around, as I said, life and organisms on the planet. And certainly what they got out of them would have been something different. However, the range of text in these selections is different. There's several different grade level text ranges, and they're very engaging. The text in them is easy to read. It's accessible, but there's also quite a lot of interesting content. So nobody was bored. Everybody was able to find something that they liked, and nobody was also so challenged that they couldn't find something they could access. So before I show you the actual examples, I'm just going to show you one per kid. The benefits of this sort of approach, where you have different kinds of possible content for students to choose from or find, and an open-ended kind of project, whether that's a slideshow on technology or a video or a Prezi or an Animoto, and these are all pieces of tech that allow students to be creative and to and basically to pace themselves and figure out what they want to do. This is kind of the height, I think, of where differentiation can go and needs to go, and if we are able to do that, we would have a lot more happy students, content students, and students who are actually learning things as they go. One of the most amazing side effects for me as a science teacher who sees students for only 40 minutes a day is that every single student did complete this, some version. And I did get things besides the slideshow. I got a couple of essays, I got a couple of note takers, I did get one poster, and I'm not demonstrating those because I think we're real familiar with kind of those products. But students really did choose from the thing that they thought was most interesting to them. Now, in the end, this is not a substitute for the, in my case, the practices of science and the actual performance tasks that we have in our standards, but it is a way to increase literacy and engage interest and create a way to ask questions that do come all back to similar things that I want to be focusing on in the lessons. And I will get better at doing that. I can't say that this time was excellent. Also, one of the things that I want to make sure people know in terms of my philosophy, I believe that technology should be there and used in service of the curriculum and the content and the learning that students are doing. So I'm not an advocate for we do something with tech just to do the tech and learn it. And we have classes for that. Our computer science classes, our technology classes, times our students spend in a computer lab, they're learning the skills for how to use them. They're going to learn skills with us too, but I don't want to just use technology for it to be fun. I want it to be in service of some other deeper learning. But I do have to say that if students are able to use technology and have some freedom in what they choose to do, just like if they were choosing an open-ended project or open-ended writing prompt, they are more engaged and they are more likely to give me their focus and attention as I need it through the rest of the unit. So all in all, it's a very worthwhile sort of approach. So here are some examples. And these are just the first pages of fourth grade's interpretations of that prompt. You'll notice you're not going to see a lot of bullet points. I thought that was interesting. Their minds think in terms of paragraphs, whether they're accurate or not. I did note that nobody seemed to be copying out of these texts. They really did seem to be summarizing. And some enjoyed images more than others. Some got quite a lot more content in them than others. And I'm going to go fairly quick. The point of showing these is to basically highlight that students will do different things with them. I also selected here a range, and you can't tell, I think, of students in terms of whether they have an IEP, whether they're identified as AIM. All of that is represented in here, and it's pretty hard to tell the difference. I think that you'll notice that actually most of them are quite proficient in what they've come up to and what they've actually created. And that is the end of those examples. I encourage you to continue exploring how to use technology and also just how to use differentiation in our classrooms. And thank you for watching.